Alright, so the word on the street is that you need help starting with number 22. So let's start there. Oh my God. What? All right, so number 22, we're supposed to find two relationships in this problem. The first one is a little bit easier than the second one, and that is how does the perimeter of a rectangle match up with the rectangle number or whatever. So what do you notice about the perimeter numbers? They're going up by 4s. 10 plus 4 is 14. 14 plus 4 is 18. So we're going to just assume that pattern keeps going, which means this one would be 22. And that one would be 26. So to come up with the formula, since it's going up by 4s, then you know what? It's going to be 4n. Up by 4s means 4n. And then we usually have to go plus or minus something, not always, but usually. Plus 6. Good, because if I take 1 and plug it in there for n, 4 times 1 is 4. I need 10 as an answer, so I have to add 6 onto that to make it work out. So that allows us to figure out what the perimeter of the 200th rectangle would be. 806, because 4 times 200 is 800, plus 6 is 806. So that should have been fairly easy. The next part is where things get tricky, because in order to figure out how many squares are in each rectangle, we need to think about that as asking about the area of the rectangle. And how do you find the area of a rectangle? Length times width. So what I'm going to do is I'm going to make 2 more little columns here and fill those in with the length and the width. And the reason I have to do that is because from 6 to 12 is up by how much? And then from 12 to 20 is up by 8. So it's not going up by the same amount each time. What's the next one probably going to be?
10.
Yeah, go up by 10. So that's going to be 30. And then the one after that is going to go up by 12, which would be 42. But I don't want to do that 200 times to figure out what the 200th answer is. And so what I'm going to do is come up with a formula based on the pattern instead. So if you look in your book, what is the length of, bless you, of the first rectangle? 2. What is the length of the second rectangle? 3. What's the length of the third rectangle? 4. So what are these other lengths going to be? 5 and 6. And so that's an easy one because it's going up by 1 each time. What do I have to add to these to get those? Just 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. And so my formula for the length is n plus 1. So what would the length of my 200th rectangle be? 201, because of 200 plus 1. Okay, what's the width of the first rectangle? 3. What's the width of the second one? 4. And then, okay, so that's also going up by 1 each time. How much bigger are the widths than the number of rectangles? 2. So my formula for that is going to be n plus 2, which means that my 200th rectangle will have a width of what? 202. Okay, so how do we use these blue numbers to get the red numbers? Multiply. 2 times 3 is 6, 3 times 4 is 12, 4 times 50 is 20, 4 times 5 is 20, and so on. And that's because the way you find the area of a rectangle, which is the number of squares, is you multiply the length and the width. So my general formula would be these two things multiplied together, n plus 1 times n plus 2. And then my answer for the area of a rectangle with a length of 201 and a width of 202 would be, not wait what, it would be 40,602. Okay? So that's how that whole thing comes together. And I know that these are tricky. Hopefully this perimeter thing wasn't too bad. But this stuff right here is a little bit challenging. Jacob? Yeah, I don't care. Length, width, length, how you do that. Doesn't matter. Okay. McGuire? Okay, good job. Any other questions? Okay, great. Jolena?
I wasn't too sure how to do like number 4.
Number 4?
Yeah.
Numero quattro. Okay, so for number 4, what? Yeah. Yeah. Okay, Jolena, let's figure out A first. What is it? What do you call this angle and this angle? They're the same, right? So these are vertical angles, so that means if that's 60, then A is also 60. Okay? Then these two angles are called a linear pair, and they add up to 180. So if this is 60, then that means that B is 120. And then those are also vertical, so that's 120 as well. Okay? And you do the same thing down here. What's E going to be? And then how do I find B? 180 minus 65, right? Same deal over here. H is going to be, and then those two you subtract from, right? Okay? All right, let's take a look at another one of the crazy pattern ones to see if we can continue to confuse McGuire. So how about number 23?
I'm feeling 28 too. I'm feeling 28.
23, we are supposed to figure out how many pieces of string we need, depending on how many students there are. And then use that to figure out how much string we would need for 80 students. So let's make a little model here. There's one student. How many pieces of string do you need to connect that student to itself?
0.
0.
0.
If there's 2 students, how many pieces of string do you need? 1. If there's 3 students, how many pieces of string do you need? 3. It's a triangular number thing, yes. Because now if I put in a 4th student, then I need a total of 6 pieces of string. I don't know. So this one goes up by 1. This one goes up by 2. This one goes up by 3. So the next one's going to go up by 4. Okay? And then some of you said it already. It goes up by 4, sorry. So that means that the answer will be 10. I was distracted by Nate's talking. Excuse me. So some of you recognize this as what formula? The triangular numbers formula, which you're going to see a lot. It's n times n minus 1 divided by 2. Okay? And so if I want to know how many pieces of string I would need for 80 students, what do? Plug it in for n. So 80 times 79 divided by dose comes out to be 3,160 pieces of string. Okay? All right, so 24. The funny thing happens. This time we are looking at lines and intersections. And so if I have one line, how many intersection points are there? 0. If I have 2 lines, how many intersection points are there? 1. If I have 3 lines, how many intersection points are there? 3.
Wow.
It's the same freaking thing, because now if I put in another line there, I'm going to have 1, 2, 3, 4, 5, 6. And so 0, 1, 3, 6, 0, 1, 3, 6, those are exactly the same. So how many intersection points will I have if I have 80? 3,160 points of intersection.
25.
We're going all the way here now, it's all good. We're going to go write it out, 25 through 28. So everybody just roll. And then 25. Okay, so now they're making this a little bit trickier. They're going to say there's 20 couples at a party, and the couples aren't going to shake hands with each other, but they're going to shake hands with all of the other couples. So if I have one couple, how many handshakes will there be? 0, because they already know each other. It'd be like if my wife and I went to a party, we're not going to shake each other's hand. Hi, I'm your husband. Oh, hey, nice to meet you. We got that figured out already. Okay, if there are 2 couples, so here's a couple and there's a couple. 1, 2, 3, 4. And they don't shake each other's hands because they're already a couple.
I thought
Okay, but now you know, right? Now you know. So this person is going to shake both of the other people's hands. So I go to a party with my wife, and no, never mind. That'll be too crazy. All right, so let's throw another couple in there. Okay, now this person is going to shake hands with all of the people that are already there. And then this person also is going to shake hands with all the people that are already there.
we missed one on operation.
Oh, it's possible. How many new handshakes did I add? 8, because this person shook hands with 1, 2, 3, 4 people, and this person also shook hands with 1, 2, 3, 4 people. So now it's going to be up to 12.
Is it triple?
Okay? Well, no, because 0 tripled isn't 4. Okay? And also, if I threw in another couple, since there's already 1, 2, 3, 4, 5, 6 people here, they're going to add 12 handshakes because they're going to shake 6 people's hands and they're going to shake 6 people's hands. So that would be 24. Okay? So this went up by 4, then by 8, then by 12. So now we're going to go up by 16, which would be 40. So now we are ready to come up with a pattern. Okay? And again, the way to figure this out is to break it down and look at how many handshakes. I'm going to go per, should I go per person or per couple?
Per person.
Per person?
Couple.
Okay, so this one would obviously be 0. Now if I have these 2 couples and those 2 couples, how many handshakes does each person engage in? 2. And then if I throw this other couple in here,
3, 4.
now each person, because 2 new people showed up, has 4 handshakes to deal with. So what's the next one going to be?
6.
6. Because it goes up by 2 each time, which makes sense. If I'm in a party and a couple shows up, then I'm going to shake 2 more people's hands than I have already. So it goes up by 2 each time. Okay, well then I wouldn't be at the party in the first place. So this is going up by 2 each time. So that's going to be 2n. What do I have to add or subtract to make it match up? And I know this is the hard part, but the way I think about this is if I take 2 and plug it in there for n, I get 4. 2 times 2 is 4. But I wanted 2 as an answer, so what do I have to do to get that? Subtract 2, so that's going to be 2n minus 2. Now this should be easy to figure out how these numbers in the middle come from this column and that column. What do I do with this and this to get this thing in the middle? What? How do I take 1 and 0 and get 0, 2 and 2 and get 4, 3 and 4 get, nope, 12, 4 and 6, multiply. All I'm doing is multiplying this by this. So my formula is n times 2n minus 2. Okay? So if there are 20 couples there altogether, what do?
Dividing the handshake number.
I do 20, because that's the n, times 2 is 40, minus 2 is 38. So what is it?
800. No, never mind. Wait, how do you get the n?
Well, did you see I got the 2n minus 2?
Yeah.
Okay, these numbers here in the middle are just the outside ones multiplied together.
Oh.
So since this is n and this is 2n minus 2, I just multiplied them together.
Oh,
So you got that. Okay? All right, so you get 760 handshakes.
746. That would suck. That's okay.
All right, 26. Just keep playing. Now we are looking at what just happened there.
Logan.
Logan?
It's hard. That's the person I'm talking to.
Okay, number 26 says if a polygon has 24 sides, how many diagonals are there from each vertex? So this is diagonals per vertex. And then it also wants to know the total number of vertices. Okay, so what's the fewest number of sides we can have in our polygon? 3. So if I have a triangle, how many diagonals can I draw? 0. So that gives me a total of 0. If I have a 4-sided figure, then I can draw 2 diagonals. So I have a total of 2 diagonals. How many diagonals do I have coming out of each vertex? 1. And then a 5-sided figure, there would be a total of 1, 2, there's a star, so there's 5, bless you, total of 5 diagonals. How many diagonals per vertex? 2? 2 coming out, no, not counting the sides, 2 coming out of each corner, right? Okay, so that should be enough for us to come up with a pattern. If I had 6 sides, there would be 3 diagonals per vertex and a total of 9 diagonals. Bless you. Because this is the easy one, it's going up by 1 each time. This is a little harder, it goes up by 2, then by 3, then by 4. Okay? So how do the number of sides relate to the diagonals per vertex? Since those are going up by 1 each time? N minus 3, yes. And then the trickier piece is the total right here. But we've been doing this pretty much all last week, and so hopefully you're picking up on the theme. What am I going to do with these 2 numbers? Multiply them together and then divide by 2. And that works because 6 times 3 is 18, divided by 2 is 9. 5 times 2 is 10, divided by 2 is 5, and so forth. So my formula is that. And then they want us to figure out what the answer is for a 24-sided polygon. So there would be 21 diagonals per vertex. And then if you multiply those 2 numbers together and divide by 2, you get, yes, 252 total diagonals. All right? Okay, we're almost there. All right, next one sort of turns this idea on its head, and it says instead of figuring out how many diagonals there are, let's go backwards and say that it has 560 diagonals, and then we have to figure out how many sides there are. So what was the formula we just came up with? N times n minus 3 divided by 2. And we need to solve that for n. So what's the first step? Times both sides by 2. So that's 1,120. And then I believe I mentioned this the other day, that there is some algebra that we could do that would give us a solution here. But a guess and check is a good way to go too. So somebody guess. 40? All right, so let's see if 40 works. What do I have to multiply 40 by? 37, yeah, because it's minus 3. So I want to see if 40 times 37 equals 1,020, and it doesn't. It's not too far off. Too big. Make another guess.
35.
35? Okay. What do I multiply 35 by? 32, because that's 3 less. 35 times 32 works out. And so the answer is that we must have had 35 sides if we ended up with 560.
What would be the algebra?
The algebra way to do this would be to distribute the n.
Why?
So that gives you n squared minus 3n, because you have to multiply both of them by n, right? Then since it's a quadratic, I'm going to get everything on the one side. So I'm going to rewrite this as n squared minus 3n minus 1120 equals 0. Okay? And then I'm going to factor this. So I need two numbers that multiply together to be 1,120 and add together to be -3. And it turns out that those are -32 and -35. And so that gives me my, oh no, that's not going to work. One's got to be a positive, one's got to be a negative, yeah. So negative, right, -35, +32, thank you. So then your two answers are n could equal -32 or +35, but we can't have a negative number of sides, so we throw that out and say 35 is used. Okay? So that's the algebra way that someone like McGuire would like to do it. Okay, 28. A midpoint divides a segment into two congruent segments. So let's make a little sketch of that. So here's my midpoint, and there are my two congruent segments. Point M divides segment AY into two congruent segments, AM and MY. What conclusion can you make? Right, point M is the midpoint. And what kind of reasoning did we use to figure that out? Deductive. We never looked at a pattern, we used a definition. So that's deductive reasoning. Deductive seasoning.
Honestly,